The first session today will be chaired by two persons, by Janos Kartaš from Central European University in Vienna, and by the co-organizer of today's Ising lectures, Oksana Dobush from our Institute for Condensed Matter Physics of the National Academy of Sciences. With all this said, I pass the chair to you, dear chairpersons.
Good. Thank you. Thank you very much. And let me start with our first speaker, who is Yurij Holovatch, who everybody knows. Nevertheless, let me say a few words about him. Yurij Holovatch is a professor and chief researcher at the Lviv Institute for Condensed Matter Physics of the National Academy of Sciences of Ukraine, where he has founded a laboratory for statistical physics of complex systems. He has achieved important results in the field of phase transitions and critical phenomena in disordered magnets, complex polymers, and complex networks. He is full member of the National Academy of Sciences of Ukraine. In addition to carrying out excellent research, Yurko is known for his selfless service to the community, let it be the editing of the World Scientific Review series Order, Disorder and Criticality, or the organization of the Ising lectures, which has become a great tradition in Lviv by now. Holding the torch of science high in these difficult times of war is particularly honorable. Yurko, the floor is yours.
Thank you very much. Thank you very much for this presentation, and thank you very much for our contacts, for our friendship. Present as a slideshow. Sorry, now I will start. Now, basically, you saw all my transparencies. Today's meeting is dedicated to these two events. One is the 100th anniversary of the Ising model, and one is the 100th anniversary of Igor Yukhnovsky, who is our teacher in Lviv and who founded our Lviv School of Statistical Physics. You know, when preparing to make this presentation, I thought it would be not that complicated because I worked with Ising model. I knew Yukhnovsky for many years, and then I saw it's in fact very hard. And basically, the reasons are two: that you who are working in the field, many of you know more about and know better about Ising model. Moreover, there are many people who are present here who collaborated with Yukhnovsky much more tight as I did and who knew him much better than I did. On the other hand, there are people for whom something which I will tell is completely new. So I should find some way not to be trivial, but to give also to say something new to people who knew Yukhnovsky and who worked with the Ising model. To start with, you know, I thought just looking on their faces and on the dates of their life, what came to my mind that they are similar and they are very different, you know. The difference is that for Ernst Ising, all people say he is the author of one paper. In fact, that's not true because he is the author of two papers. The other one was published in American Journal of Physics in 1950s, but that's a short one. So he did one thing, he did one paper, he is famous for this paper. Whereas Yukhnovsky, as you see from the motto, which is on the upper part of the transparency, he founded the school. There are many directions, there are many people behind him, he taught many students, they produced many results, so that's the difference. Another thing is that personally for me, when I was a student, when I started my scientific career, Ernst Ising was somebody from the beginning of 20th century. I saw this name in textbook, I had this name at the conference. I never thought that Ernst Ising could be my contemporary. And then I was really astonished when in 1997, attending a conference in Poland, I met Professor Sigismund Kobe from Dresden, who told that he visited Ising and his wife Johanna in States, that Ising is alive, that, well, he told me some stories from Ising's life. With Yukhnovsky, that's different. For Yukhnovsky was always with me. I got acquainted with him, with his family, with his children when I was a schoolboy. So, and he, as you see, he left us recently, one year ago. Speaking about similarities, that's different. Speaking about similarities, you see from the dates of their life, right? Both lived long life, long eventful life. They were both 1980 years old when they passed away. Also, only looking on these dates, you see that both witnessed two big wars. Ernst Ising saw the World War the First. In fact, he was at the military training. He never was a soldier in the army, serving in the army, but he was in military training, and there is his memoir about the last day of the war and so on. And then the Second World War, when Ising tried to survive, staying in, being arrested by Gestapo and then staying in the Jewish deportation center and so on. So two wars for Ising. Now Yukhnovsky. Yukhnovsky during World War II, he was a soldier. He started to be in the army in 1944 and up to 1946 he served in the army. He finished the war in Austria. Then Yukhnovsky, together with us in Ukraine and together in you all over the world, witnessed the large-scale invasion of Russia in Ukraine. And some people already name this, that it is World War III. Some people are just afraid and they are aware that it might be transformed to World War III. So, and last but not least, speaking about similarities, that Ernst Ising, that's the one who solved one-dimensional Ising model. Whereas Igor Yukhnovsky, that's the one who was working with the three-dimensional Ising model. So with all this said, I decided to make my further presentation in such a way that in the first part I tell you some facts, I share with you some facts about Ernst Ising and his model, and the second part will be devoted to Igor Yukhnovsky. So Ising defended his thesis in Hamburg University. So his way to Hamburg was the following. He was born in Cologne to the family of Gustav and Tekla Ising, and soon the family moved to Bochum, where he attended gymnasium. He got attestation, matura. She was for military training. And then she did his studies in the universities. It was in Göttingen and it was in Bonn. Prepared for the scientific research, he went to Hamburg, where he was a PhD student of Wilhelm Lenz. And that's the dates in red where he stayed in Hamburg, where he was dealing with the Ising model and where he defended his thesis. You see the dates of thesis defense. It was July 24, and in December he submitted the paper to Zeitschrift für Physik about the Ising model. As far as I understand, he was never interested, at least after the defense, he was not interested on continuous scientific career. First, he was in Berlin working in General Electric company. Then he was teaching physics in the famous boarding school in Salem. It is near Bodensee, near Constance. And then he decided to continue working in state school, and for this he needs additional diplomas. And he went to Berlin University, where he was studying philosophy and pedagogy. That's where he met his future wife, Johanna Emmer, who was economist, did her doctorate there. And they got married. And there is a very nice book of memoirs of Johanna Emmer Ising, which she named Walk on a Tightrope of Paradise Lasted a Year and a Half. So this paradise of year and a half, that's the time when they got married, and Ising got his first position as the Studienassessor, that's the state position for the teacher in gymnasium, and it was in Strausberg. Strausberg is almost Berlin, very close to Berlin. And then further to the east, he was working in Crossen am Oder. So they were happy. She was working in Berlin. He was not far away. They were hiking. They were reciting poems. Goethe was a famous poet. And then started the part of the life which Jane Ising named Walk on the Tightrope. In fact, these memoirs of Jane Ising, by permission of the family, they are available on the site of our institute. They are typewritten, they are really kind of very nice memoirs of the witness of this period. You are very welcome if you are interested to read them. So Nazis are coming to power in Germany. Ising is dismissed from his position. He starts working as a teacher of mathematics, of physics in the Kaputz, that's near Potsdam, in the boarding school for Jewish people who were not able to visit usual schools. Soon he becomes the headmaster of the school. So he had to deal not only with teaching, he had to deal with how to run the school. There are also interesting stories behind. Nearby was the summer house of Einstein. They were using this house for children, for the staff. He was, taking care about children during and after pogrom. He was saving them, leading them through wood to escape from this place. He was arrested by Gestapo. And after interrogation, he was released, and then the family moved to Luxembourg, which was not yet occupied, with an intention to leave for the United States. And in fact, all documents were ready for leaving, but they didn't manage. One document was missing, and Luxembourg was occupied. And they stayed in Luxembourg the rest of the war. It was very hard time also when you read these memoirs. They were, for example, for the part of time, Ising was working in the deportation center in St. Fontaine, that's Fünfbrunnen Monastery. That's a place where elderly and ill Jews were kept, and then they were sent to concentration camps. So every time he was witnessing how the life of many of his compatriots is going to the end. That's an interesting picture. In the middle, it is the son of Ernst Ising, Thomas Ising. He visited this place in 1980s, and there is a street there. So in blue, it's written Rue Ernst Ising Physicien. So he got from the major of the city this plate and carried it back home. And below it is Ernst Ising wife, so mother of Thomas, who is carrying in hands this template. By the way, interesting life of Jane Ising. She was born the 2nd of February and she passed away the 2nd of February. And between these 2 days, it was 110 years. She was born in 1902 and she passed away in 2012. 110 years old she was when she passed away. Luxembourg was liberated by Allies, and finally they arrived to New York. And only then, already in the United States, Ising learned that there exists something in physics, in physical, mathematical, in culture of natural sciences, which is named in Ising model. Because before he was not thinking about science, but he was thinking how to survive and how to allow his family to survive. One of the reasons he managed to survive was he was Jewish and his wife was Christian, and for this family it was slightly different as for entirely Jewish families. So in the United States, he became teaching in different places, and finally he ended in Bradley University in Peoria. He was very much acknowledged by students and by the university staff. You can read it from the memoirs, from the letters, from different papers, but he never did science afterwards. It was teaching, contacts with students, and he got finally retired, and he passed away the next day. So he was born the May 10, 1900, and he passed away, you see, May 11, 1998. So it is one of the reasons we name this meeting Ising Lectures in May. So in fact, last Saturday. It was 10th of May, and it was 125th anniversary since Ising birth. So several words about the place and the atmosphere in which this Ising model was formulated and was studied. Alma mater, in the sense of doctoral studies, alma mater, it was Hamburg University. And from now on several transparencies in the bottom in gray color, I show the dates when Ising stayed in Hamburg. And in blue, it is the date, or the rather dates, when the people I mentioned stayed in Hamburg too. Wilhelm Helens had the chair for theoretical physics. He was the supervisor of Ernst Ising. And you see that the time when Lenz arrived, it arrived slightly later from Rostock. Wolfgang Pauli was assistant to Wilhelm Lenz. Then Institute of Physical Chemistry was run by Otto Stern from Stern-Gerlach experiment, which was performed later. And to say, Nobel Prize laureate, of course, and to say about this Hamburg University, I can cite the paper of another Nobel Prize winner, Rabi, who told about Hamburg University that it was one of the leading centers of physics in the world, and Stern's and Pauli presence attracted many illustrious visitors to Hamburg. Bohr and Ehrenfest were frequent visitors. So the thesis itself, the picture you see here, that's the photo of the thesis, which is in the library of Hamburg University. That's the title of this thesis. And the structure of the thesis is the following. That's 4 major parts. One is about what we call now one-dimensional Ising model, the first part. The second part is more complicated cases. In fact, what is interesting, up to my knowledge, up to our knowledge, the second part was never published, and it's almost never discussed in scientific community, in community even of those who are dealing statistical physics. And it is also very interesting. So this was also the reason why several of us decided to work more on the thesis. That's Reinhard Voigt, Bertrand Berge, and our late and dear colleague from Coventry, Professor Ralph Kenner. We started the project. We decided to make the translation of Ising thesis, to publish it bilingual in 2 languages, in 2 columns, left column in German, right column in English, to provide commentaries and some facts from Ising biography. And I'm happy to tell you that this book is going to be to appear this year in the Well Scientific Publishers publishing house. So there are 2 main ingredients, 2 main concepts, which are very important for Ising model formulation. One is due to Lenz, who then was in Rostock. It was in 1920, and he published a paper in Physikalische Zeitschrift. And there he describes the following, that although elementary magnetic moment in principle can be directed in any direction, there is some reason in the solid state, there is some symmetry, which tells this magnetic moment can point only up and down. It can turn out around only by 180 degrees. He calls this Umklapp process. So this Umklapp process is very important. So to say it establishes the symmetry of the model. Then interaction. At those time, only 2 interactions were known to people, gravitation and electromagnetic force. Of course, gravitation has nothing to do with, probably has nothing to do with this spontaneous magnetization. Then electromagnetic force. What was clear that it could not be dipole interaction, because if you say that these are 2 dipoles which interact, the interaction will be too weak to explain such high experimentally observed Curie temperatures. And then it was the idea of Schottky, and this idea is not that acknowledged now. He thought in terms of old Bohr model of atom, thinking about electron which is circling around the nucleus, and this electron can circle around clockwise or counterclockwise. And in this way, the magnetic moment can be up and can be down. And then for 2 neighboring nucleus having 2 electrons, both can circle in the same direction or in opposite directions, and it will cost different energies. So it was the important ingredient, and Ising cites Schottky in his thesis, but he doesn't cite it in the paper. And that's why afterwards, it is almost never acknowledged, this contribution of Schottky to the appearance of Ising model. That's the result of Ising. It is scanned from the paper. You see the paper contribution to the theory of ferromagnetism was published in 1925. That's why this year we celebrate 100 years since Ising model was published as a paper. This formula shows magnetization as function of magnetic field. Magnetic field is proportional to this value, which is written here as alpha. You see alpha. And sign is sign hyperbolicum. So it tells you when the magnetic field is zero, spontaneous magnetization is also zero, which is in fact disappointing. But here you have the approval of Lenz of the thesis, the supervisor of Ising, who already then acknowledged and evaluated highly what was done by Ising. He states that it is rather complicated probabilistic considerations what Ising did. And he says that although the result is negative, it is an important conclusion for the continuation of the theory. Nevertheless, at the end, Lenz puts mark. And you see what is the mark? Predicate. Predicate is mark. At the beginning, he wrote good. And only afterwards, here you see in this citation signs, he added they're good. So excellent. So for some reason, maybe it is because still you don't have magnetization in one dimensions, but it was at the beginning, it was written as good. Then it was a long way to go to the object which now we know as Ising model. So the origin of this interaction, which leads to the spontaneous ordering, the exchange interaction, was formulated by Heisenberg in 1928. The Hamiltonian for the first time was written by 1930 by Pauli. Ising model, Ising thesis didn't contain the Hamiltonian. It was so to say, without Hamiltonian, only considering different combinations of different probabilities having energies for parallel and anti-parallel configurations of interacting magnets. And then, I write several more dates. I will not stop on them. You know these names and you know their results. I only say you that the method which we show now to students when we explain them one-dimensional or two-dimensional Ising model, the transfer matrix, was also not to hand at 1920s. It was invented in 1941. So Ising solved one-dimensional Ising model without Hamiltonian and without transfer matrix. And then step by step, this gave origin, the studies of Ising model gave, and of similar models gave origin to the theory and of phase transitions and to our modern understanding of phase transition and of critical phenomena. In 1950s, the tools of a field theoretical randomization group appeared, which then successfully and successively applied to the Ising model in particular, gave rise to understanding of these concepts of universality and of scaling, which we observe in many cases in nature, not necessarily in the objects of traditional, which are subject of considerations by tools of statistical physics. Last but not least, I already started to tell about this. These are complex systems where Ising model is widely used. And the reason it is used, it's not only it is conceptually simple, it's not only it is, there are many tools to solve it, and it nicely fits now the computer simulations. There is one more reason behind this, which I think is the major reason to apply this way of thinking to understanding of complex systems. This reason is binary opposition. It is connected to our cognition, to how do we, by our consciousness, how do we recognize the world? How we put it into two identities, yes or no, for or against, up and down, yin or yang. All this together is nicely reproduced by the Ising model having these two states. And well, probably one of the earliest written references to this binary opposition, which is behind Ising model, is here. It is from the New Testament. when it is said, but let your speech be yes, yes, no, no, and whatsoever is more than this is of the evil one. I finished this part of presentation, which is devoted to Ising and his model, by small announcement that this year, because of this 100 universities, we will have the topical issue of European Physical Journal B, which is named 100 Glorious Years of the Ising Model. And I know that some of you who are present today during this workshop have already submitted their contributions to this model. And if somebody else wants to join, you are very welcome. You see there are 2 months and a half more. You are welcome to submit the paper. Now, since we are passing to the second hero of today's celebrations, to Igor Yukhnovsky, I finished here by the special issue, so I start the second part of my presentation by another special issue. There's a special issue of the journal Condensed Metaphysics, and it is devoted to 100th anniversary of birth of Igor Yukhnovsky. This issue will appear very soon in June, so it is almost ready. But in addition, we will have focus on collections. So all papers which will be submitted up to the end of this year and which will hold dedication to Yukhnovsky 100th anniversary will be collected to this focus on collection. So below you have the link, the address of the Institute of the Journal Condensed Metaphysics, and again, you are welcome to submit to this special issue your contributions. Now about Yukhnovsky, you know, for easing the way to his PhD, defense was the way to Hamburg. For Yukhnovsky, it was the way to Lviv. On the upper map, I show you the map of Ukraine, and in red color, I show the place, which is village Knyaghinine, where Igor Yukhnovsky was born. We call this historical region of Ukraine, we call it Volyn. And I looked to Wikipedia to learn that in English it is named Volhynia. So that's the name of this historical province. And below this red sign here, it is the city of Lviv. So you see it is northwestern part of Ukraine where Yukhnovsky was born. He attended primary school in his region. And then the important institution in his education, is a picture of it is shown below. It is Lyceum of Kremenets. That's a prominent educational institution. In some books I read, they call it Athens of Volyn. You know, that's a prominent educational institution which was founded in 19th century. And Yukhnovsky kept very dear memoirs about time when he was there. It was very nice lessons of literature, of fine arts, of music. By the way, he was a good painter. He was painting oil on canvas up to the end of his life. And of course, natural sciences and literature and so on. Then in 1939, to this region of Ukraine, because of Molotov-Ribbentrop Pact, the Soviets came and this educational system was changed. Then again, after the 22nd of June 1941, Germans came. And so it was interruption in his education. He was in the forestry college, and then again the war is coming from the east to west, and finally in 1944 he joins the Soviet army, the Red Army, and he became a soldier, and he was a soldier for 2 years. That's a picture of him young as a soldier during army. As I told you, he was in Czech Republic, Slovakia, and then he finished his war in he stayed after the war for some time in the troops of Allies in Austria, and then returned back to Ukraine in 1946, the same year. He inscribed and he entered Lviv University. It was his dream during the war. He always thought that he will go to the university. I will not tell you much about the university. I use the occasion again to advertise the book. The reference to the book is below. It is in English, and I would say it is in good English. It was edited by native speakers, and it is about Lviv, generally about science in Lviv in the first half of 20th century. That's exactly the time when Yukhnovsky entered the university. And this book is about exact science. You have here physics, you have mathematics. And the book is also available as a hard copy, but also available online. So if you are interested, you can read. So in general, I say that Lviv University is one of the oldest universities in this part of Ukraine. Oldest university is this part of the world, and the oldest university in Ukraine. And under Austrian rule, it was named Franz I University. Then during Third Polish Republic, it was Jan Kazimierz University, and now it is named Ivan Franko National University of Lviv. So physics and mathematics, again, I give only the names which are relevant for the 20th century. In mathematics, it was Václav Sierpiński, Hugo Steinhaus, Stefan Banach, and this Lviv Mathematical School. And here are also the teachers who taught Yukhnovsky when he came to the university: Miron Zaritsky, Volodymyr Levetsky. Then in physics, at the beginning of 20th century, Martin Smoluchowski moved from Vienna to Lviv University, and then in the course of the Second World War, he moved to Jagiellonian University in Krakow. And Vasily Milyanchuk, that's again one of Yukhnovsky teachers. There were other institutions of higher education in Lviv, including Shevchenko Scientific Society, which had foreign members as David Gilbert, Einstein, Planck, and Krylov, who was teacher of Bogolyubov, and again, Bogolyubov was one of the teachers of Yukhnovsky. Then the students of the university, young group, 1948. Yukhnovsky told us that first year in the university was especially hard for him because some children came, boys and girls came directly from school, and he was from the army. So he was working hard the first year, and then being the second year students, he felt himself very easy in studies. The topic the field he was working in, it was theoretical physics, statistical physics. And statistical physics, his way of understanding statistical physics is closely related to ideas of Bogolyubov. That's the time when Bogolyubov worked in Kiev. That one of his books, Lectures on Quantum Statistics, which in fact was published for the first time in Ukrainian, and then it was translated to English, to Russian, to other languages. And Yukhnovsky's supervisor was Abba Glauberman. That's other story. He came to Lviv after the war. He was partisan during the war in Belarus in particular. And he came to Lviv, and he was a student of Yakov Frenkel in Leningrad. And to the left, it is Vasily Milyanchuk, one of those who taught Yukhnovsky physics during his university times. At the same period, Yukhnovsky meets his future wife, Nina Vasilyevna Yukhnovskaya. She was a chemist. She studied chemistry in Lviv University, and they lived long and happy lives. For us, they were a kind of example of a couple of people who loved each other and who conduct their family, and who can really serve as example for many others. That his defense, his thesis was named Binary Distribution Function for Systems of Interacting Particles. It was expansion in plasma parameter to understand certain properties of ionic solutions. Yukhnovsky founded the first department in statistical physics. In Lviv, it was department of Bogolyubov Institute of Theoretical Physics, which is in Kyiv. And then he was working in Lviv. Soon department became division. Soon division became the institute, and that's how our institute was born. That some people from our institute, I stopped telling names because they are numerous, and some of us who are here from Lviv know them by faces. And speaking about directions, main directions of the research which was initiated by Yukhnovsky and then continued by the students, his students, whom you see here and who are much more numerous, were the method of statistical physics, theory of electrolyte solutions, where the method of collective variables allowed to take into account short and long-range forces properly to take them into account, quantum many particle systems, including theory of interacting Bose Bose gases, theory of liquid helium-4, mixtures helium-4, helium-3. Phase transition, critical phenomena. I show next transparency on that, so I don't comment. And finally, after Chernobyl disaster, all these problems related to Chernobyl and which can be where physics, theoretical physics can be helpful, were also considered by Yukhnovsky and his students. That's the paper, that's early 70s, and here it is written application of collective variables to the Ising model, partition function. So from this preprint, there were then many papers where that's the direction similar to what we call now functional randomization group of exact equations of randomization group, which were initiated here this direction by Yukhnovsky and his students. And that's the book which finally summarized this research. That's our institute. And, you know, I want to show you this nice picture. It was inspired by our colleague Alexander Ivankov, where you have the woodcut by prominent Ukrainian graphics Yakov Gnezdovsky, and each fruit on this woodcut holds the name of one of Yukhnovsky's students. And you know, behind many names, there are again many other students. So indeed, it is a big group of people who worked, who is working, and who probably will continue working in this field of statistical physics. These are some of his books I translate who don't know Ukrainian. Foundations of Quantum Mechanics, Selected Problems in Physics, Statistical Theory of Classical Equilibrium Systems, and so on. You know, beginning of 90s, Ukraine becomes independent, and Yukhnovsky starts to be he was politically active, but then now this political activity was open and was a part of the state activity. He was member of parliament of 4 convocations. For us in Ukraine, you know, in physics, his name is familiar because of his work in physics. But in general, people in Ukraine, I tell you frankly, they know his name. This name is in our textbooks. In 1991, we had referendum. So Ukraine got independence as many other republics of former Soviet Union, because after the putsch, it was announcement of parliaments of these republics that these republics become independent as independent states. And it was decision of Yukhnovsky to suggest from the tribune of parliament, let us do in Ukraine referendum to ask people whether you want to be independent or not. And in fact, it was rather dangerous question, and many people were not happy about this, because they were afraid that maybe not many people will go to vote, and maybe some of them will vote no. And you see the outcome. You know, 90% of people who voted for this Ukrainian in the referendum, they voted, they told yes. And it is one of the foundations of modern Ukrainian state. Even his candidacy was considered for the president of Ukraine. He was first vice prime minister of Ukraine. I like this picture. He was the leader of the first opposition in our parliament, and he's in the middle of this picture, and you see deputies of our parliament. Then one of the events on the Maidan, it was this Orange Revolution on Maidan. Yukhnovsky was deputy, and many colleagues from our institute came to Kyiv to show their solidarity, to participate in manifestations, and they are here with Yukhnovsky. Then several pictures of him with prominence of our political elite. You see Patriarch Mstislav, President Kravchuk, President Kuchma, President Yushchenko. One more direction, one more field where Yukhnovsky was the initiator is Ukrainian Institute of National Remembrance. That's the institution which takes records about facts from the history of Ukraine which were hidden, in particular about what should we call in Ukrainian Holodomor, which is this intentional starvation or famine. They wrote, 20-volume book where they listed the victims of this famine. They built what you say in German language, Mahnmal, this memorials in memory of people who died for different reasons during Stalin regime. So this Ukrainian Institute of National Remembrance is active up to now. And then the 90th birthday of Yukhnovsky, many of our institute also participated in it. Being 90 years old, he climbed the highest peak in the Ukrainian Carpathians. And here you see his granddaughter, great-grandson, and academician Briglot, academician Bakai, who was, and Yukhnovsky is also academician, so three academicians standing near Ukrainian flag, and one of them is this year, on this date, he became 90 years old. So I come to the end of my story, of this story I was going to tell you today. Again, showing you these two pictures. And you know, in physics, we read articles, we read books, but sometimes we know nothing about personal life of the person who created some formula, who obtained some result. Sometimes it is not important, but I think in these two cases it's very important. You know, I never knew that somebody who created one-dimensional, who solved one-dimensional Ising model was interrogated by Gestapo and tried to survive in the deportation center in Frunzen Monastery. Now, probably some people didn't know that somebody who was solving three-dimensional Ising model, that's the person who announced a referendum which announced independence of Ukraine. So the question is, does the history teach us something? Some people say that knowing the history makes us more clever, more wise, and teach us. I show you, I am almost through my presentation. I show you two facts, two citations from the life of Ising and from the life of Yukhnovsky. This citation and to think whether history teaches us or not. This citation is from the life of Ising. It is 1933 when he was dismissed from his position, and finally he was struggling to save his life and life of his family and life of his pupils. So here, you know, German intellectuals appeal to intellectuals all over the world, asking them to join the efforts in the struggle initiated by Adolf Hitler for freedom, honor, justice, and peace. So that's fact from Ising life about which I was telling you during first part of my presentation. Now the part from life of Yukhnovsky. It is year 2022 when the full-scale invasion of Ukraine became evident for all over the world. And you have, again, the very similar rhetorics, very similar announcement now by Russian intellectuals who say that they are defending their security, they are supporting their president, and it is what they do. It is very difficult, and it is very necessary. So that's one of the conclusions, say whether the history teaches us something. And another conclusion I want to show you, that last transparency of my presentation is the following. You know, many of you who attend this workshop are complexity scientists. And in fact, also we are using our knowledge to understand sometimes, sometimes to predict something which is going on in particular in society too. And one of the warnings which was done by complexity scientists, it was in May 2018, and it was during the meeting in Complexity Science Hub, Vienna. I believe some of the attendees of this meeting can even recall themselves as attendees of this meeting where Imre Kondor made his talk. And in this talk, you know, he was speaking about complex systems and about how it is dangerous to make some disturbance in the complex systems, and especially when the system is close to the tipping point. And then the words which I emphasize here, and that's the last words of my transparency, were 7 years ago, in May 2012, Imre Kondor, as a complexity scientist, told us that with the highest alarm that I see, the rise of clowns and Führers who propagate toxic ideologies which we believed had long been buried in the permafrost of the past. And in fact, it was said in 2018, now it is 2025, and I share this verse of Imre Kondor. And by this verse, I want to finish my presentation, and I thank you for attention.
Thank you very much, Yurko. Thank you for this interesting talk, this parallel lives of two remarkable persons. I don't know what is planned, whether there is room for questions or discussions. We have 10 minutes or so before the next talk.
So these 10 minutes are, the intention is the following. If there are some questions, not only for me, but for future also, we can start them by replying questions, and then we stay discussing with us, having coffee and so on.
Good.
So I see Lucas Watch raise his hand, so please, Lucas.
Yeah, thanks, Yuko, for the very interesting presentation with all of these historical remarks. I was wondering in the like current political system in Ukraine, because you talked a lot about these historical figures, are scientists, and in particular natural scientists, represented in these political decision bodies? And I'm also asking because in other countries and in the European Union, right, I think there's maybe an overrepresentation of certain fields, not so much natural scientists. And you talked about two very famous examples of natural scientists. So is this still the case that they are involved in these decision-making processes in Ukraine?
Very good question. You know, I witnessed this period, 1990. I was already, you know, working, having family, having children, working in the institute. You know, then for our first election, it was enough that we believe that the man is, you know, not a thief, that he is not somebody from these liars who were ruling our country before. In this sense, as Yukhnovsky told us, that, you know, our politicians were grown up in prisons. So our first parliament, they were poets, they were scientists, you know, and especially natural scientists, because usually, you know, in Soviet period, when somebody go to social sciences, it's already not really the social science you will rely on. Yeah. Then people, many of them, my father was biologist, for example, Wisnowski was physicist. They were going to natural sciences also to have a room where they can do real things and they can be honest with what they are doing. So back to your question, first parliament, poet, scientist, plus strong part of this communist elite from old times. And then with time it shifted. I am not, you know, very attentive, and in this sense, I cannot tell you in details, but probably there are people who study the percentage of natural scientists or humanitarians in the parliament. My opinion is it is diminishing, and it seems to me that more people from much more people from other fields come to our parliament. But as a layperson, that's my opinion. But indeed, he was a physicist, and it was additional reason to choose him as a member of parliament. That's true.
Are there any questions? Can raise your hand or speak. Yes, of course.
I would like to say several words. My name is Alexander Chali. I am from Kiev, and my profession is in physics is phase transition theory and critical phenomena, together with applications in the medical physics and biological physics. And I would like to say that it was a great pleasure for me to hear this presentation given by famous physicist Yurij Holovatch, academician of the National Academy of Sciences, professor. And it was very important for me to that our lecture unified two biographies and two directions of the studies, famous physicists Ising and Yukhnovsky, which are very close for me, and I use these results, many results of these famous scientists in my publications, in my work and lectures for students. Thank you so much.
Thank you, Professor Charles. Thank you.